In this video, we are going to discuss the objective question. So question number 1. Which of the following are secondary alcohol? So let's classify first. This is the alpha carbon bonded to 2 carbon, so it is secondary alcohol. This is the alpha carbon bonded to 2 alkyl group, secondary alcohol. This is the alpha carbon attached to 1 alkyl group, so this is primary alcohol. So the question is asked for secondary alcohol, so the answer is 1 and 2. Question number 2. What is the major organic product from the reaction of 3-methyl-2-butanol with HBr? So we can draw out the structure of 2-butanol and then hydroxyl group, and then next we are going to have the methyl group CH3, CH hydrogen and CH3. So as we know that there is only one functional group, which is the hydroxyl group. So when the hydroxyl group react with the HBr, the bond will break between H and Br, and where hydrogen is electrophile and bromine is the nucleophile. So the OH plays the role as the nucleophile, so will replaced by the Br. Then now the substitute for this compound is 2-bromo and 3-methyl butane. So the answer is C. Question number 3. When compound X react with hot concentrated sulfuric acid, compound Y is produced. So from here, we roughly can predict that the X is the alcohol, and then react with concentrated H2HO4 will produce the Y, which is the alkene. And then compound Y decolorize acidified potassium manganate 7. So from here we can confirm that the Y is alkene, because so far the homologous series that we already studied, only alkene will react with the acidified potassium manganate 7, but the alcohol X does not. So just now we predict that alcohol X is the X is the alcohol, but then it will not react with the acidified potassium permanganate. So indirectly that we have the idea that the alcohol X is tertiary alcohol. So then compound Y react with hydrogen bromide according to the equation. So the Y is the alkene. Alkene react with HBr will produce haloalkane. Okay, so what is the X? So just now we already identified that the X is the tertiary alcohol. So based on the name here, 2-butanol is secondary, 1-propanol is primary, 2-propanol secondary, 2-methyl-2-propanol is tertiary alcohol. So that's why the answer is donkey. Proceed to question number 4. In order of increasing boiling point. So when mention about boiling point, we have to relate to intermolecular force. So the first compound consists of 2 hydroxyl group. Second one have 1 hydroxyl group. The third one have 1 hydroxyl group, and then the fourth one have 2 hydroxyl group. So as we know that the hydroxyl group will be able to let us form hydrogen bond. So when more hydroxyl group, we have more hydrogen bond can be formed. So the boiling point will be higher. So then now we look at what's the difference between compound 1 and compound 4. Definitely this one have 2 carbon, and then the compound 4 have 3 carbon. So and then the carbon group here we consider the alkyl group. So the alkyl group we will relate with the van der Waals force. So for the van der Waals force, will become stronger if number of carbon is more. So therefore, here we will notice that compound 4 have more carbon, so the boiling point is higher. Okay, when van der Waals force increase, boiling point also higher. So and then the second higher is the 1. So that's why the option A and C is out already. So then now we have compound 2 and compound 3. However, we notice that both compound 2 and 3 consist of 3 carbon and 1 hydroxyl group. So the next factor that we may considering is 1 propanol is more tightly packed. Okay, when it is tightly packed, the boiling point is higher. So that's why 2 is the second lower, and then the lowest boiling point is the compound 3. So the answer is B. Okay, so now we continue with the objective question for the phenol. So which of the compound below has the lowest pKa value? As we know in semester 1, if the pKa value is lower, means that the Ka value is higher, and then the acidity is greater as well. Okay, so with this we can end up the conclusion that a lower pKa value indicate it is a stronger acid. So when we look at the option A until D here, so these are the difference. Okay, here have the NO2, B doesn't have any substituent, C have CH3, and then donkey have the ethoxide substituent. So for this substitute, actually, if you still remember in chapter introduction, we learned about electron donating group and also electron withdrawing group. So from here, the NO2 is this one. So it is the EWG. So okay, we can write down here first. NO2 is EWG, but then from here we didn't see any CH3 or OCH2CH3. So again, the CH3 basically can be represented with the symbol of R. So the OCH2CH3 also the same, because the part of CH2CH3 is the alkyl group. So if it is not in the list of EWG, so has the most probability the alkyl group and the OR is the electron donating group. So at where we can see here, the R, okay, so is the electron donating group. The OR also electron donating group. So let us remark first. This is the EDG. This one also EDG. Okay, then we can look for another statement over here. They mentioned that EWG will increase the acidity. Okay, so that is definitely the answer. Which one is stronger acid? So the answer will be A. Okay, next question, number 2. Phenol can be differentiated from 1-propanol by using bromine in CCl4. Okay, bromine so far, if you go through the notes and also the summary that you have, no matter it's alcohol or the phenol, they will not react with the bromine. So even though bromine shows the changes or may have the color, but since both of them will not react with the bromine, so the color of the bromine will be remain in both condition. So that's why A is not the answer. And then so normally bromine in CCl4 is used positive result towards alkene. While for the fairing, we will learn in chapter carbonyl. So potassium manganate 7, yes, possible. So phenol will not react with the potassium permanganate. However, the 1-propanol is the primary alcohol. So primary alcohol can undergo oxidation. So one has changes, one doesn't have changes, then you also can differentiate the alcohol with the phenol. D is tolerance reagent. Tolerance reagent also will be learned in chapter carbonyl. So answer for question number 2, no doubt, is the C. Okay, next one we will look at question number 3. Which of the following reagent can be used to distinguish the phenol with 2-methyl-2-propanol? So 2-methyl-2-propanol is tertiary alcohol. So when we look at here, PCl5 is relate with the, yes, they can relate with the 2-methyl-propanol, the tertiary alcohol. Okay, and then for the phenol, no reaction. However, basically, there is no obvious observation, even though one react and then another one have no reaction. So that's why option A will not be chosen. And then for the bromine water, we know that the tertiary alcohol have no changes, but there will be changes for the phenol, and then you will get white precipitate at where the product should be 2,4,6 tribromo phenol. Okay, option C, yes, will react with tertiary alcohol, will not react with phenol. Again, because HBr doesn't have any special color, so we cannot see the changes. SOCl2 also the same, will react with the tertiary alcohol but will not react with the phenol. And due to no obvious changes, so option D will not be accepted. So the correct answer for question 3 is B, because we can see beside the reddish brown decolorized, and then we can see what precipitate is formed. So generally, I already discussed all the tutorial, all the objective question in the tutorial question in both subtopic of aliphatic alcohol and also phenol. So in next video, we will going to do a summary of the alcohol. Okay, see you in next video. Bye bye.